Hi everyone, welcome to our first virtual lesson. Today we're going to talk about the trigonometry that you're going to see on paper 2. Section 3.1 in the textbook talks about the cosecant, secant, and cotangent ratios, which are simply the inverses of our trig functions, sine, cosine, and tangent. So cosecant is 1 over sine. Secant is 1 over cosine. And cotangent is 1 over tangent. So this is on your reference sheet, which you should be using. Oh, let's see, no, this is not on your reference sheet, which I have right in front of me. So during this chapter, you're really going to need your reference sheet. I'll post a copy on Google Classroom in case you didn't bring yours home with you. But it's going to be your best friend in chapter 3, so have it around. Okay, so we know that sine is opposite over hypotenuse. If we flip that, the cosecant is hypotenuse over opposite. Cosine is adjacent over hypotenuse. So secant is hypotenuse over adjacent. Cotangent is 1 over tangent. Well, since tangent is sine over cosine, then cotan is cosine over sine. The way that I remember, each one of these two has an S and a C. So since this is cosecant, starts with a C, it's actually the inverse of sine, which has an S. Same thing here. Secant is the inverse of cosine. So secant, S, inverse of cosine, C. Okay, so in this chapter, we're also introduced to some new trig identities. 1 plus tan squared theta is equivalent to secant squared theta, and cotangent squared theta plus 1 equals cosecant squared theta. Now remember that you should be rearranging these formulas depending on what you need. So if you're trying to replace tan squared theta in a problem, you would be replacing it with secant squared theta minus 1. So be flexible when using these trig identities in your work. In the first example from this chapter, we're asked to find the exact value, so radical form, etc., of the cosecant of 240 degrees. This is equivalent to 1 over the sine of 240 degrees. If you have the unit circle memorized, that's great. I always like to draw a picture just to be sure. So 240 degrees takes us into the third quadrant. This in itself isn't that helpful, but if we find our reference angle by subtracting 180 from 240, we get a reference angle of 60 degrees. Now in the third quadrant, my adjacent side and my opposite side have to be negative. If this is 60, it's a 30, 60, 90 right triangle. The side opposite the 30 degrees is 1/2, negative 1/2. The side opposite 60 degrees, negative root 3 over 2. And the hypotenuse is always 1 That's why it's called the unit circle. So I need the inverse of the sine of this triangle here. Sine of 240 equals negative radical 3 over 2. It's always going to be over 1 in the unit circle as the hypotenuse, so we can ignore that. If I want the cosecant of 240, then I just flip the sine ratio. Negative 2 over radical 3. In the book, they didn't rationalize the denominator, but you can go ahead if you want. Negative 2 root 3 over 3. That's the exact value of the cosecant of 240 degrees. As we look at example 2 and read the question, there's a couple things I want you to note. As with all of our trig problems, I want you to look at the range of answers. This will determine which mode to put your calculator in. And as you know, if you do this problem in radians, it's going to give you a wrong answer since it tells you clearly your answer should be in degrees. Also, be on the lookout for problems that are in the general form of a quadratic equation. Something squared x, something x, and then a constant equals 0 is for sure a quadratic function. However, we're going to need to get it in terms of one single type of trig function. So let's look at our identities on our formula sheet and see what I can do with this secant squared. The trig identity I will use here is secant squared theta equals 1 plus tan squared theta. And once I replace this, it will all be in terms of tangent. So 1 plus tan squared theta. Sorry, I interchanged x and theta. It doesn't matter if you do or not. Secant, or 1 plus tan squared theta minus tan theta minus 3 equals 0. So before we can factor our quadratic, we need to combine the constants. 1 minus 3 is negative 2. So let's factor just as if it's a normal quadratic. Tan theta minus 2 times tan theta plus 1 equals 0. Okay, so because I have factored, now I can say that tan theta is equal to 2 or tan theta is equal to negative 1. Solving for theta, theta is the inverse tangent of 2 or the inverse tangent of negative 1. When I plug this in my calculator in degree mode, the answer I get out of the calculator is 63.43 or 135. But remember, there are 2 tangent ratios in the unit circle that are going to provide me with the same answer. Remember, all students take calculus. The tangent angles are equivalent in diagonal quadrants. So because of that, I can find the other angle by adding 180 degrees. The second answer for 63.43, add 180, you get 243.4. 243. And if I add 180 to 135, I get 315. So be sure not to forget that each of these trig functions has two possible answers within the unit circle. So in Chapter 3, Part 2, we're introduced to compound angle formulae. This just means we're adding or subtracting two angles and then taking them to our trig ratio. This is what you'll see on your reference sheet. So the sign on the top, if you have a plus here, it's going to be a plus. If you have a minus, it's going to be a minus. But I'm going to just write them all out for you so you can see what they should look like in case this is confusing. So when you have sine, it's sine of the first angle times cosine of the second angle, and then you keep the same sign, times sine, or plus sine of the second angle times cosine of the first angle. So since it's a plus, it stays a plus when it's sine. Therefore, if it's a subtraction, a minus b, it's still sine a cosine b, but we switch it to minus. Minus sine b cosine a. For cosine, we do cosine of the first angle times cosine of the second angle, and then we switch the sign. Becomes minus, and then sine of the first angle times sine of the second angle. So then the only thing that would change if I switch it to subtraction in here is that the sign in the middle becomes the opposite, which is positive. Okay, and now we look at our tangent formula. If I'm adding angles A and B, I add tangent of A plus tangent of B. So the sign is the same in the numerator, and then the sign flips in the denominator, where I have 1 minus tangent A times tangent B. And when I change to subtraction, tangent of A minus B, I keep the sign in the numerator, tan A minus tan B, and then I switch the sign in the denominator. 1 plus tangent A times tangent B. So these formulas are useful when you're given an angle that is not one of the common angles from the unit circle. So we want to figure out which of our common angles will either add or subtract to 105 degrees. Well, 60 degrees and 45 degrees add up to 105. So now I have sine of two angles that are added together. So since I have addition, you multiply sine of the first angle times cosine of the second angle, keep the sign the same, and then sine of the second angle times cosine of the first angle. And since it's exact values, they do want radical form for your answers. So we need to talk about our 30-60-90 ratios and our 45-45-90 ratios. And these are all going to be positive since 60 degrees and 45 degrees are in the first quadrant. On a 30-60-90 triangle, the shorter leg is 1/2 and the longer leg is √3/2. And on our 45-45-90 triangle, both legs are equivalent and they are equal to √2/2. So the sine of 60 degrees, it's the opposite side, is root 3 over 2. And the cosine, the adjacent side to 45, hello. So yeah, sine of 60, root 3 over 2. Cosine of 45, root 2 over 2. The sine of 45 is the same as cosine of 45, but the cosine of 60, which is the adjacent side, is 1/2. So we'll multiply these terms and these terms. Root 3 times root 2 is root 6 over 4. And this becomes root 2 over 4. And we'll combine it into a single fraction. Root 6 plus root 2 over 4. Here we're being asked to work backwards. Which of the trig identities... So now we're being asked to work backwards. Which of the compound angle formulae has cosine times cosine plus sine times sine? Or if it's the cosines together and the sines together, that's going to be one of my cosine compound angle formulae. Okay. And are these numbers going to be added or subtracted together? Well, remember that with cosine, we switch the sign. So since I have addition here, this is equivalent to the cosine of 42 degrees minus 12 degrees. (42 minus 12 is 30. And what's the cosine of a 30-degree angle? The opposite side is 1/2, and the adjacent side is root 3 over 2. So my cosine of 30 degrees equals radical 3 over 2. So this question reads, it is given that sine A is 4 over 5 and cosine B is 5 over 13. Angle A is obtuse. This means that's going to be in quadrant 2. And since angle B is acute, that's in quadrant 1. So if this is angle B in quadrant 1, the adjacent side is 5 and the hypotenuse is 13. If you know your special or your Pythagorean triples, you'll know that it's a 5, 12, 13 right triangle. If you don't, you can just go ahead and use the Pythagorean theorem to find the missing side. Sine of A is 4 over 5 and it's in quadrant 2. So this means the opposite side is 4 and the hypotenuse is 5. You should recognize this Pythagorean triple as a 3, 4, 5 right triangle. However, this is in quadrant 2. While the sign is positive, the adjacent side will be negative. So on a problem like this, I would go ahead and find the sine, cosine, and tangent ratios for each of these angles before we move on to the actual question. This will come in handy, I promise. So sine of A is 4 over 5. The cosine of A is negative 3 over 5. And the tangent of A is negative 4/3. The sine of B is 12 over 13. The cosine of B is 5 over 13. And the tangent of B is 12 over 5. So, given our compound angle formulae and the information we've just figured out about our triangles, they first asked us to find sine of A plus B. Let's rewrite this using our formula. Sine of one angle times cosine of the other. Keep the sign the same, and then switch your angles. So now, since I already have all my trig ratios for those triangles, I can simply plug them in. Sine of A was 4 over 5, and cosine of B is 5 over 13. The sine of B is 12 over 13, and the cosine of A is negative 3 over 5. So this will become 4 over 13 minus 36 over 65. And my final answer is negative 16 over 65. So here we're asked to find the cosine of A minus B. With the cosine ratio, it's cosine of both angles multiplied together. Switch the sign in the middle from negative to positive, and then both signs multiplied together. So we'll use our values that we found earlier and substitute them in. This becomes negative 3 over 13 plus 48 over 65. When I add them together, I get 33 over 65. Okay, let's use those same ratios in practice with a tangent compound angle formula. In the top, I add or subtract the tangents of each angle, keeping the sign the same as the original. In the denominator, you have 1 first, and then switch the sign, and then multiply the tangent ratios together. Now use substitution of the values. Negative 4 over 3 minus 12 over 5 is my numerator. I know fractions. And in the denominator, 1 plus those two fractions multiplied together. When you work all of this out in your calculator, you should get an answer of 56 over 33. Example of the day. We're asked to solve an equation using a compound angle formula, and our answer must be between 0 and 360 exclusive. Make sure your calculator's in degree mode before you start typing anything in there. I'm not going to simplify the right yet, so let's rewrite the left side of the equation using our sine formula. Sine of the first angle times cosine of the second. Then I'll do subtraction because sine stays the same. Minus sine of x cosine of 60 degrees. And that's equal to 2 sine x. Now we know the exact values of sine and cosine of 60 degrees, so we'll use substitution there. Sine of 60 is root 3 over 2, and that's multiplied by cosine of x. Cosine of 60 is 1/2, so I'm going to subtract 1/2 sine of x. I don't like dealing with denominators, so I'll multiply everything by 2 and get rid of those. Here it cancels to root 3 cosine x. Here it's negative 1 sine x. And don't forget to distribute the 2 to the right side, and we have 4 times sine of x. I'll add this sine of x to the other side, so I have my cosines together and my sines together. 4 sine x plus sine x gives me 5 sine of x. Now, there's no substitution I can do that will make cosine of x or sine of x become the same term. So that means we need to use a trig function that has both sine and cosine, and I'm thinking that's going to be tangent. The tangent of x, or sine over cosine, equals the square root of 3 over 5. Therefore, x is the inverse tangent of the square root of 3 over 5. And the calculator gives me 19.1 degrees. But you need to remember that there are two answers in the unit circle for this trig ratio. And since it's tangent, I'll add 180 degrees. So 19.1 plus 180 degrees is 199.1 degrees. And those are my two answers. So write down any questions you may have about the homework. I am available by Remind, email, on Google Classroom, etc. all day. So whenever you need help, just reach out. I will be setting up office hours. And yeah, I hope you all are doing well and glad to be talking to you.